I'm Jim Joros, and this is your PLCHero Weekly. Hello. Today I want to share with you the very foundation for troubleshooting, and that is defining the problem. Troubleshooting is a systematic way of solving a problem. The end goal of troubleshooting is to determine why something doesn't work as expected and how to resolve the problem. Effective troubleshooting requires the following elements. Number one, a thorough understanding of the process. If you don't know how it works, then you're not going to fix it. Number two, identifying the problems in a systematic approach. Number three, identifying possible causes. And number four, resolving the problem. Element number one, understanding the process. In this example, when the solution is below the low-level sensor, the sensor is energized and on. When the low-level sensor is on, the discharge pump is off and the solenoid valve is energized and the product begins filling the tank. When the solution rises above the low-level sensor, the sensor is de-energized. The tank level continues to rise until it reaches the full-level sensor, shutting the fill solenoid off. When the solenoid is de-energized, the mixer motor turns on and runs for a predetermined amount of time. After it times out, the mixer motor shuts off and energizes the discharge pump motor. When the level drops below the full-level sensor, the sensor is de-energized and is off. The level will continue to drop until the low-level sensor turns on. When it turns on, the discharge pump shuts off. This cycle will continue as long as the system is enabled. This sequence of events can be graphically represented. The order of events represents the processor scan and becomes the norm for the process. When a deviation occurs from the norm, it will become necessary to identify the problem, its cause, and how to take corrective action. Knowing the sequence of complex processes can be used to reduce a deviation to a single event. Comparing the deviation to the norm and asking yourself fact-finding questions will identify the what, the when, the where, and the how factors. Questions you might want to ask. When does it happen? Is it repeatable? How does the system fail? Are other systems affected? Is it intermittent? Does the problem occur when the same task is being performed? Does the problem happen only at a certain time of the day or night? By asking these types of questions, it will create a laser focus on the cause of the problem. Correcting the problem. Knowing what event failed will direct you to the starting point. Working backwards from this point will reveal the sub-events that failed, preventing the task from being accomplished. Again, in way of review, effective troubleshooting requires the following elements. Number one, a thorough understanding of the processor. And again, if you don't know how it works, then you can't fix it. Number two, identify the problems in a systematic approach. Identify the possible causes. And number four, correct the problem. Some additional tips to consider would be take one problem at a time. Number two, keep notes of the changes you made and the results of them. And number three, Create a current copy of the program whenever you go online so you have a trail of breadcrumbs. And number 4, make sure you check the revision notes when you go online. If you want more, make sure you join us at PLCHero.com. It's a great place to network, to learn, to share your experiences, and to advance your career.